Here we're given the function f of x equals the square root of x squared plus 5. So we're here to graph the function between 1 and 6. So here are my x values that I'm going to be dealing with. I need to find the y values, so I'm actually going to plug those values, 1 through 6, into the equation to find out what those are. I'm going to go ahead and use a calculator so I can get kind of decimals or rounded answers to actually put this on a graph. Okay, so here is where I get my values from by plugging 1 through 6 into the equation, squaring it, adding 5, and then taking the square root. So in these here, I'm going to go up. My lowest value is 2.5-ish, and my highest value is about 6.5. So 1, 2, 3, 4, 5, 6, 7. I'll plot these points here real quick. So maybe not the best graph here, given I think it kind of curves up-ish if I were to remember that correctly, but we'll call that good enough. Again, just because what we're really looking for, what's really important when we're solving this is a little bit less of the graph itself. That's going to give us the visual, but really what's important is these y values. Because when we're talking about these y values, it's going to help us answer letter B here. Because it says to approximate the area under the curve given the interval by using both 5 left endpoint rectangles and 5 right endpoint rectangles. So I'll do the left side here in red and the right side here in blue. So the reason that these values are so important is because these are really going to tell us the height of each of my rectangles. The width, super easy. If you look at this here, when I create them, I'll start with my left endpoint. The left endpoint should be the height of my rectangles. So when I'm doing the left endpoint, here are my 5 rectangles. 2 things to notice here. First of all, the left side, so my first x value and my first y value, that here gives me my height on the left side. Then the second value that I have here is my second height. And then we keep going until we get to the last one, my 5th rectangle, my 5th height. And then you should notice here that we don't actually use this point here when we're dealing with the left endpoint graphs. So what that means is that when I'm using this for heights, I'm really only using these 5 values for my heights. And then my widths are just the distance between my points here, which all of these are just 1. So when I'm dealing with this problem here and I go through, I'm going to basically add together, let me see here. I'm also going to add one extra thing here. I'm going to call these in subscript notation, these here, x of 0 through x of 5, because that is going to help us once we start dealing with sigma notation. Right now, it's just showing us that, again, when we are dealing with the left endpoint rectangles, we're only using the first 5 here. Then with the right endpoint, we're going to use the right side, and I'll show you that one in a second. So I'm going to multiply the length times the width. Because the width is 1, it's just 2.45 times 1, 3 times 1, 3.74 times 1, 4.58 times 1. And so really that gives us the area of each of these as really just the height. So this one's kind of easy on the math side of it. But all I have to do is find the area of each of those and then add them together, which, again, with my rounded values, I'm going to get 19.25. When I do that, another thing to note is that this is an underestimate of my actual area, because if you look at this, there's all this extra space left over that we're not including with the area under the curve. So that's an underestimate. For the right endpoint rectangles, let's see if I can erase this well enough so that I can still use the same graph here. Erasing my arrows. Beautiful, beautiful, beautiful. All good. Okay. So for my right endpoint rectangle, I'm going to redraw them because basically I'm going to use the right side of my rectangle for the height. So what that means is that I got this here for my rectangles. And now a couple of differences that we make here. So what happens is the height of my first rectangle is actually the second point, or the second x value that we use, and the second y value that we find. So again, what we're not using is this first one because we don't use this height here. So my first height is here, my second height is here, and so on, and I actually use this last point here. So again, my width is still just 1. So to find the area of each of these rectangles, I do length times width. I know this value here is 3, so I'm going to 3.74, 4.58, 5.48, and my last one 6.4. So there's the areas of all of my rectangles, and then when I add them together, my estimate here, not exactly perfect because of my rounding, 23.2. And again, remember here that this one is going to be an overestimate because I have all of these extra pieces on top of the graph, so I'm really overestimating my answer. So I know my actual answer is going to be between these two values.